Hi friends, this is the second lecture in the lecture series for the preparation of GATE in Mechanical Engineering. Since this is the second lecture, please go through the first lecture for getting a better understanding. Today we will be dealing with general form of Fourier's law. General form of Fourier's law. In the last class, we explained the Fourier's law as q dot by a is equal to minus k dt by dx. So here this q dot a is heat transfer rate and this a is the heat transfer area. This k is thermal conductivity. This dt by dx is the temperature gradient that is existing in the medium. So this equation is only in the one direction, that is particularly in the x direction. So the general form of Fourier's law, which simply extends this Fourier's law into three dimensions. So this general form is simply the extension of Fourier's law in three dimensions. Therefore, in x direction, we can write q dot by a in x equal to minus kx dot t by dou x. In y direction, we can write q dot by a in y direction will be equal to minus ky dot t by dou y. In z direction, we can write q dot by a in z direction will be equal to minus kz dot t by dou z. So in all these three equations, we can see a common factor which is q dot by a, and this is the ratio of rate of heat transfer to the unit area, and this term is called the heat flux, which is denoted as q bar, and this heat flux is a vector quantity. Please know that this heat flux is a vector quantity, and this vector quantity is something that is having both magnitude and direction. Since this heat flux, which is represented as q bar, which is equal to q dot by a, is a vector quantity, we can write in general q bar is equal to I into qx bar plus j cap into qy bar plus k cap into qz bar. Therefore, further expanding, we can write I cap into minus kx dot t by dou x plus j cap into minus ky dot t by dou y plus k cap into minus kz dot t by dou z. Okay, therefore we can write this heat flux in general heat flux is equal to I cap into minus kx dot t by dou x plus j cap into minus ky dot t by dou y plus k cap into minus kz dot t by dou z, and this is the general form of Fourier's law. This is the general form of Fourier's law. Suppose we are having a medium or the material which is isotropic in nature. That is, for isotropic material or medium, what happens here that this kx thermal conductivity values in x direction will be equal to thermal conductivity in the y direction will be equal to thermal conductivity in the z direction, which is represented as letter k. So we can write this equation into q bar will be equal to minus k I into dou t by dou x plus j cap into dou t by dou y plus k cap into dou t by dou z, which can be written as q bar is equal to minus k del dot t. Okay, so the general form of heat conduction, there is therefore general form of Fourier's law can be written as q bar will be equal to minus k del dot